My name is Mark. I'm an engineer. I've worked at a car company for 2 decades, and we're going to share 5 cool car facts that will blow your mind, or at least entertain you while we show you some stuff you didn't know. And the first is the insane places cars get tested, from deserts to ice fields. They go to hot places like Phoenix, Arizona, where they drive up South Mountain Park, a twisty path in the desert heat. Or Bullhead City, where the grade leading east from Davis Dam is part of the SAE test for official tow ratings. They go to Las Vegas, Nevada, where Las Vegas Boulevard is the perfect place to see how vehicles handle stop-and-go traffic in extreme temperatures. California's a popular spot too. Places like Baker, home of the world's tallest thermometer, and a long, steep grade heading east out of town. But before you leave, you have to hit the Mad Greek for milkshakes. And the granddaddy of all hot places, Death Valley. As beautiful as it is rugged and dangerous, you haven't lived until you've experienced 120-degree heat and climbed from near sea level to almost a mile in elevation, heading west from stovepipe wells. Sometimes they even go to more exotic places, like Dubai. They go to cold places, like Minnesota. Bemidji's one city they test in. Another is Baudette, home to a large testing facility called TRC Minnesota. Unfortunately, they don't have any media kit materials, so you'll just have to imagine this picture from Google Earth covered with snow. They also test in the Upper Peninsula of Michigan at a place called KRC near Michigan Tech University. The hardcore will travel to Thompson, Manitoba in Canada. It's not the North Pole, but it's pretty close to being so far north, the only way you can go is south. Sometimes they need to do cold weather testing when it's not winter. Then they'll use places like the McKinley Climatic Laboratory at Eglin Air Force Base. The main hangar can reach temperatures of minus 65 degrees Fahrenheit and is big enough to drive around it. And if the McKinley lab is too small, there's always the Southern Hemisphere Proving Grounds in New Zealand. They test in the mountains, in places like Loveland Pass, Colorado, or Pikes Peak.
And do you remember where the ice patch was?
And hauling max payload up Eisenhower Grade. They test off-road in places like Moab, Utah, and the Rubicon Trail in California. And every automaker has custom-built proving grounds tailored to the way they make cars. Sometimes they even go reasonable places, like doing a seat comfort test in Florida in February. If you think your headrest is a pain in the neck, you're not crazy. You see, before 2009, headrests were designed to support your head in a comfortable, ergonomic position if you sat with proper posture. But in 2009, a law was changed, the Federal Motor Vehicle Safety Standard 202, which said the headrest couldn't be more than a maximum distance from the passenger's head. But because of the way it was measured, it caused a real person's head to be pushed way forward when they sit normally. This change was driven by the insurance industry to improve safety. In response to the pain in the neck issue, NHTSA modified the regulation to allow active head restraints that move forward in a rear collision, but these are also more expensive. So if your car is giving you a pain in the neck, you can thank your insurance agent. What's this? A recall? Does this mean my car's a lemon? Getting a recall does not mean your car's a lemon and irretrievably bad. Often, a bad batch of parts will make it into the production process. When that happens, the first step is called containment, figuring out which cars were built with the incorrect parts and not building any more. Parts are designed with traceability, such as part numbers, batch numbers for groups of parts, or unique codes linked to specific vehicles. This system helps manufacturers pinpoint which cars need repairs. Next, we figure out why the part is bad. This is called finding the root cause. It could be a wide range of things, from an out-of-spec material, to wear on a tool, to a tester being miscalibrated. It's like when your phone won't charge. Is it the cable? Is it the port? Is it the outlet? Same idea, just on a much bigger scale. Once we know the problem, we figure out the permanent corrective action, the fix. This could be making sure the right parts get used, a design change, or maintaining tools and equipment more often. The fix gets thoroughly tested, which is called validation. Before we roll out the fix, we have to make absolutely sure it works. Nothing gets approved unless it passes every test. When validation is done, the rollout begins. The parts required for the fix are produced and distributed, any special repair procedures developed and sent to dealerships, recall letters are crafted and sent out, then all the vehicles get fixed, usually as good as new. But only if the owners bring their vehicles in. NHTSA has a site that lets you check your vehicles for any open recalls, so check the link in the description and make sure your cars get anything open fixed. So if you get a recall, it's not the end of the world, it's how things get made right. If you're enjoying this video, please consider hitting the subscribe button. It doesn't cost anything, and it helps the channel a lot. Most people know that car companies crash test their cars in many different ways. This is part of the Federal Motor Vehicle Safety Standards, or FMVSS. These standards cover everything from crash tests to brake hoses to minimum sound requirements for hybrids and electrics to how fast your windshield defrosts in the winter. Now let's watch that crash in real time. And let's watch a few more just because they're fun. But that's not all. Sometimes they shoot cars to test the armor on special police vehicles. And this one looks like it passed. This is fuel system resistance to fire, one of the tests in the ECE regulations used in much of the world outside of the US and Canada. Vehicles get punished on all sorts of off-road courses. Vehicle integration teams make sure the cars meet the customers' expectations and perform in the real world.
And here we are. Heather's getting ready to take us on an adventure in the unknown. It's going to make it better.
This SUV is doing a mud packing test, being coated with mud over and over, and at the end everything still has to function perfectly. Vehicles get tested in all sorts of ways in the worst winter weather. This is level 1 testing, and this is level 10. This snow packing test makes sure everything works even in a blizzard. Cars even drive through snow indoors on dynamometers. One of the most fun tests is finding the limits of performance on the racetrack. Hot weather is tough on all vehicles. Everything gets tested to make sure it can handle the heat while hauling a load and while slogging through city traffic. And to make sure something like this doesn't happen. You can see a lot of crazy things in the desert in the summer, even a
double rainbow all the way across the sky.
Qualified mountain road. And I should pay more attention to the roads and try to film.
Vehicles get tested in the mountains, covering everything from navigating trails to towing trailers across the Continental Divide. They get shook on 4-post shakers, which simulate a lifetime of durability without driving a mile. They also cover thousands of miles in actual durability testing. Their sound gets tuned in the anechoic chamber, whether they're looking for silent or rowdy. And they get tested for emissions and fuel economy. Vehicles must sit at 72 degrees for 12 to 36 hours, so manufacturers have warehouses full of cars and trucks waiting to be tested. Car companies usually know exactly what you want. but sometimes they can't deliver on it. Here's why. The first thing is time. We're not just talking clock time, but calendar time. Because it takes about 3 years to develop a new car from scratch. And the closer we are to the end of the time, the less they can change. The next item is money. It takes about $1 billion to build a car from scratch. The problem car companies have is their money is in the current car. And they need to get that out by selling enough of them to build your dream car. Third is emissions and fuel economy. This includes weight, power, engine type and size, and an electric mandate. And any one or all of these things can get in the way of your dream car. Safety regulations. In addition to the crash test everyone thinks of, there are fuel system integrity tests, roof crush tests, airbags, stability control, rear view cameras, child restraints, automatic emergency braking, lane keeping, and intelligent speed assist. And any or all of these things can interfere with your dream car. Conflicting features. Customers will often want things like great handling around corners, yet a smooth ride on rough roads. High power, yet good fuel economy. Great off-road chops with a quiet ride. That's a sleeping baby, by the way. And all of these things can conflict with your dream car. Feasibility. Sometimes the technology we want isn't ready yet and can't fit into that timeline we talked about earlier. Oh, didn't need to do that. Manufacturing. They have to be able to put your dream car together with the technology they have, and it really needs to fit into the existing factories. Complexity. Most car companies try to limit the number of option combinations, as more combinations mean more chances to make a mistake, and more cost in ways you may not expect, like storing and moving parts. So complexity may kill your dream car. Resources. Car companies don't have unlimited resources, and what they do have gets put on things with the biggest returns. That's a big reason there are no super cheap basic cars. And if that was your dream, this is why you're not going to get it. The last obstacle is sussing out what the customers actually want, as opposed to what they think they want, what they think they should want, and what they wish they wanted. And this is an example right here. This is the E36 BMW M3 Lightweight. This was made for homologation purposes to race. And it has everything that a BMW fan should want. It's extra lightweight, they removed the air conditioning, it's got a stiffer suspension, it's got aerodynamic bits in the trunk to bolt on. And if you talk to a BMW fanboy, they'd say, yeah, this is what I want. This is the car. But when it came time to actually buy them, they changed their mind. Wow, that's a lot of money, and it'll have to be my daily driver, and it doesn't have air conditioning, and it's got a rough ride. So these cars sat unsold on dealer lots for a long time. And that's always a danger. Asking customers what they want, you might get what they think they should say rather than what they actually want. So if your dream car isn't out there, it might be because it's not actually your dream car. So these are all the things standing between you and your dream car. Time, money, emissions and fuel economy regulations, safety regulations, conflicting features, feasibility, manufacturing, complexity, limited resources, and the need to figure out what customers actually want. If you enjoyed this video, here's another one you'll like.